Okay, good morning everyone. So today we will do our last topic of our syllabus, and that is one-dimensional heat equation. So while we start with this one-dimensional heat equation, there are certain assumptions that we work with. Okay, so I have a rod. One assumption is the heat flow from the two ends of this rod. Heat flow through the ends is negligible. The first and the second, the heat source is bounded. Heat source is bounded. Or the heat from a source, which is a heat from a source, has finite temperature. Has finite temperature, so it cannot go up to infinity. So if this is the rod, and rod is of length L, and it is heated, so the temperature uh, distribution, or what we can say, the temperature at any point is given by temperature or is given by is given by u of x comma t. So again, x is the distance from one end. So one end of this rod is always kept at the origin, and the other end is on the right hand side of the x-axis, or the positive x-axis. So this thing is always going to be there. This is also called as temperature distribution, u of xt. This is also called as the temperature distribution. Now this complete system, I mean, uh, there is a rod at the two ends. The heat flow from the two ends is negligible. Then the heat source, whatever, it has finite temperature. It cannot be unbounded in that case. And this complete system is governed by one-dimensional heat flow. So if you see, the heat flow is an there's just that is linear. I mean, it is not flowing in two direction. So if you have a plate, metal plate, and you are hitting it from the center, then the heat flow, if you see, that will be in all the direction. That is two-dimensional heat flow. Right now, when we are heating a rod, the heat that will be flowing, that will be linear. So that is, this is one-dimensional heat flow. So the system is governed by, the system is governed by governed by W by t is equal to c square u by x square. What was the wave equation? W by t square is equal to c square u by x square. So this was one-dimensional wave equation. Now we are looking at one-dimensional heat equation. The difference is there was second derivative of t in wave equation. There is first derivative of t. These are partial derivatives. Okay. For diploma students, what do we mean by partial derivative is uh, when I'm differentiating with respect to t, I treat other variables as constant. Everything else is same. Still doesn't matter. You can still solve the examples of heat equation. So initial conditions. Initial conditions. U of 0 comma t. At any time at the two ends, the temperature is 0. U of 0 comma t, U of L comma t. This is equal to 0. And the third is initial temperature distribution has to be given to us. Okay, so U of x comma 0 is equal to f of x. This condition will be for 0 less than or equal to x is less than or equal to L. So when we solve this one-dimensional heat flow equation, under these assumptions, we get a most general solution. And the most general solution, I will write it down in the top corner. The most general solution is most, because everything depends on this. If you even write down the most general solution, you will get 1 mark there. Even in theory exams, the most general solution is u of x comma t is equal to c4 cos mx plus c5 sin mx e to the power minus c square m square t. E to the power minus c square m square t. Don't forget this. What is the difference in one-dimensional wave solution? You had cos mx, sin mx, then you had cos cmt, sin cmt. But in this case, the function of t looks like e to the power minus c square m square t. Again, you can see that this is the function of x, this is the function of t. So this method is called variable separable method. Okay, for partial differential equations. Once we are clear with all the condition, method is just the same as it was earlier. But there is one more fourth condition here, which is the assumption heat source has finite temperature. So U of xt is bounded. U of xt is bounded. But this won't be of lot of use in our example. But this has to be there if we adopt this most general solution, or else we cannot adopt it. Take a screenshot, or if you are writing it down, write it down. Because I'm going to go for example now. Example. Solve W by t is equal to double to u by double x square. If u is finite, second, u of 0 comma t is 0. Third one, u of comma t is 0. And the fourth one, u of x comma 0 is equal to 3x. Zero less than or equal to x is less than or equal to pi. The most general solution here. Once we identify this is one dimensional heat equation, I can write down the most general solution. Yes, anyone? Fine. So the solution is C4 cos mx plus C5 sin mx e to the power. The value of c square here is 1 that you can see. There is 1 in the given differential equation. So e to the power minus 1 square m square t. This is very important. Now, use the first condition u of 0 comma t is 0. So, what is u of 0 comma t? So, that is going to be put x equal to 0. So, you will have c4 e to the power minus m square t equal to 0. So, e to the power minus m square t cannot be 0. So, c4 equal to 0. So, u of xt reduces to c5 sin mx e to the power minus m square t. Now use the second condition, u of pi comma t is 0. That is going to be c5 sine of m pi e to the power minus m square t. This is 0. So c5 cannot be 0. E to the power m square t is never 0. So this implies m pi is equal to n pi, where n is running from 1 to up to infinity. So what we have is m equal to n. So for each value of n, we have a solution combining all the solutions, just like the wave equation, combining the solutions. We get u of x comma t is equal to summation dn sine nx e to the power minus n square t. N is running from 1 to infinity. Now we got to use the last condition in which you have u of x comma 0. So now I will drop this part. Simply write down here m equal to n. This gives me m equal to n. Now the last condition, u of x comma 0 is equal to 3x. So we will have 3x is equal to put t equal to 0. So we have summation bn sine of nx. N is running from 1 to infinity. 0 less than or equal to x is less than or equal to pi. So this is half range Fourier sine series. Half range Fourier sine series. So for half range Fourier sine series, Bn is given by 2 by pi integral 0 to pi. What is our f of x, which is 3x sine n pi x by pi. So this will be sine of nx dx. So this is 2 by pi. That will become 6 by pi to the integration x as it is integration of sine nx minus cos nx by n minus derivative of x, which is 1, integration of minus cos nx, that will be minus sine nx on n square 0 to pi. So 6 by pi, put the upper limit minus pi cos n pi by n sin n pi is 0, and you put the lower limit, both of them are 0. So we'll have minus pi cos n pi by n. So this pi and this pi will get cancelled out. Cos n pi is minus 1 raised to n. So minus 6 minus 1 raised to n by n. This is the value of Pn. So 6 into minus 1 raised to n plus 1. So rub the initial part and write down the final solution. So hence u of x comma t is equal to summation 6 into minus 1 raised to n plus 1 upon n sine nx e to the power minus n square t. N is running from 1 to infinity. Done? No problems? Very good. Next example. a homogeneous rod of conducting material of length 100 centimeter has its end kept at zero temperature. And the temperature initially is u of x comma 0 is equal to x, for 0 less than x is less than 1. This is equal to 2 minus x, for 1 less than or equal to x is less than or equal to 2. Sorry, length 2 centimeter. In the initial question, it is 2 centimeter. Please make this change. Let's come up with our initial conditions. So as I can see, there is a heating going on there, is of a rod. So it is one dimensional. So the differential equation is to solve da by u by da by t is equal to c square da by 2u by da by x square. If the first condition u of 0 comma t is 0, second condition u of 2 comma t is 0, and initial temperature is given u of x comma 0 is equal to x, 0 less than or equal 0 less than x is less than or equal to 1. This is 2 minus x, 0 less than or equal to x, 1 less than or equal to x is less than or equal to 2. The most general solution, most general solution, u of x comma t is equal to c4 cos mx plus c5 sin mx e to the power minus c square m square t. So u of 0 comma t is 0. So if you put this, what we are going to get, c4 equal to 0. Then we have u of 2 comma t is 0. So what we have is u of x comma t after the first value of c4 equal to 0. We have c5 sin mx e to the power minus c square m square t. So u of 2 comma t is going to be c5 sine of 2m e to the power minus c square m square t. This is equal to 0. It means that sine of 2m has to be equal to 0, which gives me m is equal to n pi by 2. N is equal to 1, 2 up to infinity. So now my solution will reduce to, so u of x comma t, combining all the solutions, summation bn sine n pi x by 2 e to the power minus t square n square pi square t divided by 2 by 4 actually. So u of x comma 0 is given to us. So in this case, u of x comma 0 will become summation bn sine n pi x by 2. N is running from 1 to infinity. So this is again half range Fourier sine series where bn will be given by so bn is given by 2 by L. What is the length of the string? 2. Integral 0 to 2 f of x sine n pi x by 2 dx. What is our f of x? F of x is different in different intervals. So we break this 0 to 1 x into sine n pi x by 2 dx plus 1 to 2 2 minus x sine n pi x by 2 dx. X as it is, integration of sine n pi x by 2 minus cos n pi x by 2 upon n pi by 2 plus, minus derivative of x, which is 1. Again, an integration of this minus cos n pi x by 2 upon n pi by 2 will be minus sine n pi x by 2 upon n square pi square divided by 4. Integration 0 to 1 plus, let's do the remaining part. 2 minus x as it is, integration of sine n pi x by 2 minus cos n pi x by 2 upon n pi by 2 minus derivative of 2 minus x, which is minus 1, the 1 minus sine n pi x by 2 on n square pi square by 4, limits from 1 to 2. So in the first bracket, when you put the upper limit, the sine n pi will become 0. For 0, lower limit, both the terms are 0. So just we need to write down the first term. So we'll have minus cos n pi by 2 into 2 upon n pi. Please check the calculations. If I'm wrong, please stop there. So this is minus sign. Later, minus minus will become plus sine n pi by 2 upon, upon, I will write it down in multiplication, 4 upon n square pi square. Correct? Plus, in the other bracket, you put the upper limit and you can see that both the terms are 0. 2 minus 2, this term will become 0, and sine n pi x by 2, 2 will get cancelled out, and we can see that sine n pi is 0. Let's go for the lower limit. When we put the lower limit, 2 minus 1 is 1, and we have minus cos n pi by 2 into 2 upon n pi. Lower limit is with minus, so this will become plus. For the lower limit, there are 3 minus already and the fourth one, so that will be minus plus. Sine n pi by 2 into 4 upon n square pi square. So this minus cos n pi by 2, 2 upon n pi, this term will get cancelled out with this. So what we have is, I'll make a square and I will write it down here. Bn is equal to 8 upon n square pi square sine n pi by 2. This is the value of Bn. Just check the calculations carefully. If you have any problem, you can ask right now. Fine. Hence, mu of xt is given by hence u of x comma t is equal to 8 upon pi square, being constant can come outside summation, 1 upon n square sine n pi by 2. This is your Bn, 1 to infinity sine n pi x by 2 e to the power minus c square n square pi square t divided by 4. This is our final solution. So last example. This is for you. You should solve it. Solve w by w t is equal to 4 w2u u by w x square if first one u is finite for all t. Second, u of 0 comma t equal to 0. Third, u of l comma t is equal to 0. The fourth one, u of x comma 0 is equal to 50. 0 less than or equal to x is less than or equal to L. Find u of x comma t. Do it.
So that is 50, right, in the fourth case?
Yes, it is 50.
Yes.